Alright students, how are you all doing? Okay, in today's class, we shall be looking at functions and mapping. Alright, and we shall be looking at the various aspects of this topic. At the end of today, you should be able to understand what is a function, how to identify a mapping function, how to determine the range and the image of a function, how to identify the various types of a function, and also how to solve some problems in relating function. Alright, now what is mapping function? Mapping function is a special kind of relation which is used to establish relationship between two sets or two or more sets. Alright, now once we talk about mapping function, it refers to a system or a way of assigning some elements in a particular set with other elements in another set. One thing I want us to understand is that to every element of a particular set called set A, there is always an assignment which links that element in set A to a unique or a different element in another set called what? Set what? B. So this assignment is what we refer to as mapping function. Now, just note that not all mappings are what? Are functions. Okay, let's look at types of mapping. We have different types of mapping function. We have what we call the one-to-one mapping function, which is also referred to as the injective. We have what we call the onto function, which is called the surjective. Then we have the bijective. The bijective is a situation where a function or a mapping function is both injective and surjective. Then we have what we call the composite function. We have the inverse function and other kinds of function which I'll be looking at in this class. All right? Okay. Now let's start. Let's look at this diagram. If we are given a diagram like this, and we have another diagram like this, we have set A and set B. Set A is actually assigned to what? To set B. Let's say we have a function of f of x connecting A with that of B. If A is 1, 2, 3, and 4, and B is A, B, C, and D. And if A is being mapped, if 1 is mapped to A, 2 is mapped to B, 3 is mapped to C, 4 is mapped to D. This kind of function is called one-to-one function. Why is it one-to-one function? What is one-to-one function? One-to-one function is a situation whereby every element in the domain is assigned to a unique element in the codomain. We call this first set the domain. We call this what? The codomain. This is also referred to as the x-axis, the x. And the x represents the independent. This is also called what? The y. And the y represents the dependent. What does that mean? It simply means that the domain is called independent. The codomain is called what? Dependent. That means the codomain depends on the domain. Right? The codomain depends on the domain. Now, why do we say this is one-to-one? Although this can also be an onto function, but let's look at the analysis of one-to-one word function. One-to-one is simply when every element in the domain are assigned to a unique element in the codomain. It is referred to as what? One-to-one mapping function. Another good example is this. If we have A, we have B, we have C, and we have D. Let's say we have 1, 2, 3, and 4. If A is mapped to 1, B is mapped to 3, C is mapped to D, and 3, D is mapped to 3 as well. Okay, sorry. If D is mapped to what? To 4. This is also called 1 to what? To 1. This is also called one-to-one mapping function. Why is it one-to-one? Every element in the domain has a unique element in the codomain, meaning A is only assigned to 1, B is only assigned to 3, C is only assigned to 2, D is only assigned to 4. Sometimes, if we have, let's say, something of this nature, and probably some elements in the codomain are not assigned to any element in the domain. This is also called one-to-one because all the elements in the domain have an image in the codomain. So this is also called one-to-one mapping function. So the whole entire gist of a mapping function is that every element in the domain must have a unique element they are assigned to in the codomain. Let's see a good example. Okay, let's look at a good example of one-to-one. If we are given f of x equals to 2x plus 1, and we are asked to show the mapping of f of x, okay, given that the value of x is minus 1, 0, 1, and 2, don't forget that your x represents your domain, which is your independent variable, right? So what we are going to do here is a solution to this is simply this. We are given our f of x, right, to be equals to what? 2x plus 1. So we are given the value of x as minus 1, 0, 1, and 2. So let's find when x is equals to what? Minus 1. That is the first function, right? When x equals minus 1, that means f of minus 1 will be 2 times minus 1 plus 1, right? And that will give us what? 2 times minus 1 is what? Minus 2 plus 1. The answer is what? Minus 1. When s is 0, what do we have here? We have f of 0. That will give us what? 2 times 0 plus 1. The answer is 1, right? Because 2 times 0 is 1, 0 plus 1, we have 1. When s is 1, what do we have here? 2 times 1 plus 1. This will give us what? 3, right? When s is equals to what? 2. When it's 2, what do we have here? We have 2 times 2 plus 1, right? And that will give us 2 times 2 is 4 plus 1. And the answer here is what? 5, right? Now, we have been able to generate the codomain of what? Of this function. The codomain of this function is simply so the diagram for this equation is simply this diagram. Let's call here our A, let's call here what? Our B. A is assigned to f by what function? The function of f of s is 2x plus 1. So the value of our x, this is our domain. This is what? Our codomain. So the value of A, which is our x, we have minus 1, we have 0, we have 1, we have 2, right? Okay, we have minus 1, we have 0, we have 1, and what? 2. For the value of y, corresponding value of y, don't forget that the word f of x, the word f of x is same as your y, right? Okay, so let's bring out the value of what? Our y, the codomain. The least among them is what? Minus 1, and the greatest is what? Is 5. It simply means I will start from minus 1, just like that. So here will be minus 1, we have 0, 1, 2, 3, 4, and what? And 5. While bringing out the codomain, please don't forget to bring out all the range of value from minus 1 to what? To 5. The numbers between minus 1 and 5. Just bring them out. Now let's map. Our minus 1 is mapped. When x is minus 1, we had what? Minus 1, right? When x is 0, we have what? We had 1, right? When x is 3, is 1, we had 3, right? When x is 2, we had what? 5, right? Okay, so this is a good example of one-to-one mapping function because every element in the domain have an image in the codomain. Are you following? Now, before we go into the onto function, don't forget that we say that one-to-one is also called the injective. Also called what? The injective function. One-to-one is also called the injective function. And let's look at the second type of value function, which is the onto function. All right, guys. Before we go into onto function, let's look at how to identify a mapping function. Don't forget that not all mappings are what? Are functions. Now let's look at a good example. Look at this example here. Let's identify this. If I have A, I have what? I have B. I have 1, 2, 3, and 4. We have A, B, C, and what? And D. If A is assigned, 1 is assigned to B, 1 is assigned to A rather, 2 is assigned to B, 3 is assigned to C, 4 is assigned to D. Is this a mapping function? Yes, it is a mapping function because every element in the domain have an image in the codomain. Every element in the domain have an image in the codomain. All right? Let's look at another example. If we have this example, let's say A, and we have here to be B. Here we have 1, 2, 3, and 4. We have A, B, C, and D. If 1 is assigned to what? A, 2 is assigned to B, 3 is assigned to D. All right? Okay, and we are asked, is this a mapping function? This is not a mapping function because some elements of A are not assigned to what? Any element in what? In B. So 4, which is an element of A, is not linked to any element in what? In B. So this is not a mapping function. For a function to be a mapping function, every of the elements in A must be assigned to an element in what? In B. So 4 is not. Now, there's a simple way I illustrate this. I love using the word son and father to represent each of these components. We use son to represent the domain, a father to represent what? The codomain. Now look at it this way, like in a family or in a relation between a father and a son. Okay? Is it possible for a son not to have a father? It's not possible. But a father can decide not to have a son. This is how we can use to actually explain what a mapping function is. Look at this. 4 is a son, is it not? A son is not assigned to any father, which is never possible. Because it's not possible, that means this is not a mapping function. But a father can actually stay without a son. Because 4 is not assigned to any element in what? In B. That simply means it is not a mapping what? Function. Let's look at this. If you look at this, if this represents a son, and this what? A father. What do you notice here? Every sons have a unique word, father. Is it not? So this is a mapping function. What if we have a diagram like this? We have A and we have B. And here we have A, B, C, and D. 1, 2, 3, and 4. A is linked to B. B is linked to what? To 1. C is linked to 2. D is linked to 4. Is this a mapping function? Yes, because it is a mapping function because every sons have what? Their respective father. And a father can have more than what? One son. Are you following somebody? A father can have more than one son. So every element in the domain have an image in the what? The codomain. But this kind of function is no longer called one-to-one function. Are you there? This is called many-to-what? To one function. This is many-to-one function. Many-to-one is a kind of function whereby more than one element in the domain are assigned to a particular element in the codomain. That's called many-to-what? To one. Many people want to argue that, is this not onto function or surjective? You know, we have what we call it one-to-one. One-to-one means when every element in the domain are assigned to a unique element in the codomain. Just like this, right? This is one-to-what? One-to-one function. Then onto simply means that onto function means every element in the codomain are assigned to at least one element in the domain. That is called onto function. The reason why this is not onto function is simply because 3, an element of B is not assigned to any element in what? In A. Don't forget I said onto, which is also called what? The surjective. Okay, let me give an illustration. Let me explain. We have the first one, which is what? One-to-one, also called the injective, right? Number 2, we have what we call the onto function, which is called surjective. Number 3, we have what we call the bijective. Number 4, we have what we call the many-to-what? To one. Many-to-one. Let me explain. When you say one-to-one, I've cleared the air already. That one-to-one means that every element in the domain must be assigned to a unique, meaning one particular element in the codomain. Now, when it comes to onto function, onto means that every element in the codomain must be assigned to at least one. Every element, not some elements. The statement says every element in the codomain. Elements in the domain. That means we have what? An onto function. And another way to understand onto function is when the value of your range, when your range, which is also called the image, is equal to what? The codomain. I'll explain. So most of the time, people always get confused between many-to-one and what? An onto function. Many-to-one is when we have many assigned to what? A particular what? One. Irrespective of the fact that a member of the codomain It's not linked to what? Any element in what? In the domain. But when it comes to onto function is also like a kind of many to one function. But just that in onto function, every element in the code domain must be assigned to at least one element in the domain. By now, I believe it is now becoming clear. And also, why did we say onto? Onto means when the range is equal to what the code domain. Let me explain this. If I'm to remove 3 from here, this becomes what? An onto function. Because every element in the what? In the code domain are now assigned to at least one. At least one means either 1 or 2. 1 is assigned to more than 1, Abi? Are you following the gist now? Now, so we call this onto function. Another reason why this is also called onto is that the range or the image of this function is the same as the code domain. What do we mean by the word range? Range simply means that all the members of the elements in what? In the code domain that are linked to what? Members of what? Of the domain. And EMI talks about which of these elements in the code domain are assigned to what? Some elements in what? In the domain. Look at this now. 1 is assigned to some elements. 2 is assigned to some elements. 4 is assigned to what? An element. That means the image or the range of these functions are what? 1, 2, and what? And 4. Are you following now? And what do you notice now? The same image is equal to what? The code domain. Because if I'm to ask you, what is the code domain of B? It simply means 1, 2, 4, right? What is the image of this function? It simply means what? 1, 2, what? 4, right? So since the image and the code domain are the same, that simply means we have what we call an onto what? Function. But don't forget that in an onto function, every element in the code domain, which is the image or the range, right, must be assigned to at least one element in the word domain. But if I have an element here, 3, this is no longer an onto function. The reason because not all the elements in the code domain have an image in the domain. Number 2 is that the range of this function is not equal to what? The code domain. What's our range? Our range still remains 1, 2, and what? 4. The range talks about the image. What are the image of what? Of A. The image of A in these functions are what? 1, 2, and what? 4. But the code domain is what? 1, 2, 3, 4. So since the image of this function, which is the range, is not equal to the code domain, that simply means this is not an onto function. So if it is not onto function, then what kind of function will it be? It becomes what? Many to what? To 1. Many to what? To 1. Are you following now? All right. Alright guys. Okay, alright guys, let's look at this example we are giving here. We are asked to consider this mapping. F is such that A is mapped into B, where A is ABC, B is what? S, Y, Z, U, V. Be defined by this diagram is defined by this diagram, right? We are given this diagram, and this is the relationship given to us. So we have to find the domain. It's very simple. What's the domain? I see your domain represents your independent variable, right? Which is this. Our domain is what? A, B, and C. So we can say that from here, the domain is simply A, B, and C, right? Now the next is to find the codomain. The codomain is what? Is X, Y, and what? S, Y, Z, U, V. All of these functions there are what? The codomain. We have our X, Y, Z, U, and what? V. Then the next is our range. The range talks about the image of what? Of A. The image of this A. If this is A, the image of A means what are the elements that are assigned with every element in A? They are what? X, Y, and what? And V. X, Y, and V. So that means this is our range. Our range is S, Y, and V. Most of the times we represent the symbol for range is actually F of what? F of A. F of A, from what we have here, is actually X, Y, and what? V. So this is the image. What do you notice here in this function? The image, which is S, Y, and Z, also called your range, right? Is not equal to the codomain. So we cannot refer this as what? Onto function. But we can call this one-to-one. So the type of this function is called what? One-to-one function. Why is it one-to-one? Every element in the domain have a unique element in the what? In the codomain. Every element in the domain is assigned to a unique element in the codomain. So this is just how simple one-to-one can be, onto can be. Then when I say bijective function, a function is bijective when that function is both onto and what? One-to-one. When the function is both surjective and injective, we have what? A bijective function. Example of such. A good example of a bijective function is the fourth diagram I gave you guys. If you remember in this class, let me just say, give another one. A, B, C, D, E. I have 1, 2, 3, 4, and 5. A is assigned to 1, B is assigned to 2, C is to this is to this is to this. Okay, it might not actually be this way. It can also be in this form. Possibly maybe D is assigned to what? To 5, okay? Then E is assigned to what? 4, all right? Okay, look at this now. So if we say that this is our f of what? X, this kind of function is bijective in the sense that it is one-to-one, which is injective. It is also what? Surjective. Why do we say it is one-to-one? Because every element in the domain have an image in the codomain, right? Secondly, why do we say it is surjective? We have seen why it is injective. Why is it surjective? It's because every element in the codomain is assigned to at least one. At least one simply means either 1 or 2 or 3. Do you get the concept? And secondly again, why is this surjective? Is because the range, the image of this function, which is the range, is equal to the codomain. What is the range? The range is what? 1, 2, 3, 4, 5, right? The range represents all the images of A, is it not? And that same range is equal to the entire value of B. So that means that this is also what? A surjective what? Function. Alright guys, I'm going to stop here for now. Watch the other videos I'll be posting on composite functions. I'll be posting on inverse functions and multivariate functions, polynomial functions. There are other functions which I'll be looking at, okay? So for this, I want you guys to please digest this class. But let me just drop an assignment. I want you guys to please solve the assignment and ensure that you send your answer in the comment section. The assignment is this. If we are given f of x to be equals to s squared, determine the type of mapping function. Of mapping what? Mapping function. Determine the type of mapping function. If we have f of s equals to what? S squared. Is this function one-to-one? Is it onto? Is it bijective? Is it surjective? Please give your answer in the comment section. Thank you.